Machine learning can change your life, provided you know how to implement the right model with the right algorithm. So hello guys and welcome to my YouTube channel. So in this tutorial we're making a project named gender classification, and we are going to use a CNN technique, and we also use some Python library called Tensorflow, Keras, Opencv and so on. So let's look the demo first. So this is the demo. Click on here. Okay, so you detect my face as a male person. So if I put here some picture of the female person, you detect this person as a female. So you can see here, this is a female. Also, this is a male person, and let's put your picture like this female with marks. I think it will detect. Yep, female. So picture of the male. Yep. So it will detect the person as a male. So in this tutorial, we are going to make this one. So let's go to the ID. So I am going to use Jupyter notebook. So first check out my folder structure. So this is my folder structure. You can see here. So inside this folder, you can see here one folder named dataset and another folder named training and some file here, gender classification IPNV file. So I already code it here in my Jupyter notebook. So just I am going to open it. I will open it here. Okay. So let's check on the dataset. So inside this dataset, you can see here two folders. So first folder is the man for picture of the man, and another folder is a picture of the woman. So I collected this all picture, I mean all dataset in these in Kaggle. Yes, in Kaggle I collected this picture of the male and also the woman. So just go to the Kaggle and find the dataset of the gender classification, and you have to create a training folder. Okay, so inside this folder right now I have some what do you call, some file, because I trained my model okay before, so that's why. And you also in your folder you have to put here a file named head cascade front or default. Don't worry, I will put all this file as zip format or just file in my GitHub repo, and I'll put this link in my description. That's why you can download and just extract and run in your system. Okay, so let's load the code, minimize it and go to my Firefox browser. So this is my another video. You can see here face mask reduction using TensorFlow, Keras and Python and also Opencv. So if you miss this video, so please check it out. Okay, so this is an amazing video, so it will help us to how can I detect a person or it could be male or female, so with marks or not a marks. Okay, so you can see here marks or no marks. Okay, so in my deep learning project playlist you can find some application also like digit classification web application in CNN using TensorFlow Keras, so check it. And also the image detection using deep learning in TensorFlow, you can check it here. And also the also real-time digit classification, I made it all this tutorial in my playlist, so please check it out. Okay, I'll put this link on my description, so please check. Okay, so let's jump on the code. So you can see here gender classification.ipnb. So I actually opened this folder in my kernel, I mean control. So just you have to go to the folder and click here and type cmd. Okay, so it's better to close my internet connection, but because it will uh, hanging my computer because of the internet connection. So in my case we don't need any internet connection here. Okay, so just you have to type here Jupyter notebook and just hit enter. Okay, make sure that you need to install Jupyter in your system. Okay, make sure that you need to install Jupyter in your system and it will work. So just Jupyter notebook and enter. So it will open in a terminal. So it will, you can see here it will already open in my case. I don't know hanging why. Yep, you can see here Jupyter notebook. It will, yeah, right now it will loading some files. Jupyter notebook, when I'll open this, it will open in our default browser. So in my case is Firefox. Okay, so it will open the first page like this one. So you need to just open this gender classification IPNV file. So let's go. Yeah, so let's go to the first one. Yeah, so first what you need to do, you need to import cv2. Cv2, that means Opencv, because we are going to doing some pre-processing steps. That's why I'm going to put here the cv2. And OS for we are dealing with us into our operating system, so that's why you have to import their OS. And we are collecting the images from our dataset folder. So inside this dataset folder, you have the two folders named male and the female, or you can say main or woman. Okay. So data path equal to data sets. Okay, and we make a category of this. That's mean how many categories in this folder. Okay, so we create a list of this inside the directory of the data path, and we are iterating all the labels in a categorical format. That's mean you can see here we are creating a loop. So inside this loop, it will actually calculate the length of the categories. Is there two length or the fourth length and the fifth length? Okay, so it will calculate the length and iterate all the value into I, and it will put into the variable of level, and we are creating a dictionary of it. Okay, so after dictionary, you can see here we are using zip function, so it will help us actually to create this dictionary and create this as a dictionary for creatable in the peer-to-peer, or you can say sequence to sequence, and it will make this one is a list or dictionary. You can see here dictionary. So this dictionary is actually empty, and you are going to put all the value here. So you can see how you have to print this label dict. You can see man equal to 0, woman equal to 1. That's mean it will actually uh, first it will iterate the value of the man. You can see inside this dataset folder, you can see here two folder here. Okay, so first one is a man, so that's why it will label this man as a 0 and label this woman as a 1. That's why our I value is 0, started from 0. That's why 0 and 1, and the category is the man and woman, and the label is the 0 and 1, and it will make this as a zip format. That's mean man and 0 is a zip, and woman and the 1 as a zip, and finally it will going to make this one in the dictionary format. If I shift enter, so it will take some time to load this. You can see here man equal to 0 or woman equal to 1. So if I are going to change this one, or let's say not woman, if I put here woman as a, let's say, female. Okay, female. Okay, I think female. And if I run this code again, you can see here a little bit of some changes here. Okay, so yeah, so you can see here female as a 0 and the male as a 1. Why male 1? Cause you can see here female is right now. Okay, so we are going to do as it is one woman, or you can say woman or a male, same. Okay, just some changes. Okay, so now let's see. So we are defining our image size as a 32. You can see our image size equal to 32 right now, and we are going to create two empty lists. So first one is for data, and another one is for the target. So inside this data, we are collecting all the picture of this folder, and in the target, we are going to put here all the picture or pairwise. Yep, the target attribute 0 or 1, and we initialize our face detect hair cascade file, and we create a cascade file to detect these faces. Now we are going to iterate all the categories inside these categories. So you can see for a category in categories, we are going to iterate all the value. After iterating all the value, we are creating a list of this to joining this path. You can see us.path.join. After joining this, we are getting a list dir. That's mean creating a list of this. Then after creating this list, we are going to iterate all the values in a folder wise. You can see os.path.join in a folder wise, and we are going to read all the values. I mean all the picture in a list. Okay, and after we are iterating all the value in a list format, then we are detecting our image. So after detecting our image, we need to detect our coordinate. So you can see here for f in faces, we are detecting our coordinate here, and after detecting our coordinate, okay, we are cutting the coordinate of the picture. That's mean, let's say my picture, go here. Okay, so you can see here this is the picture of the faces. So if when you can see here some picture with some full pages, so we are going to just cut down the faces. Okay, just cut down the faces with using the hand cascade. So if the image are with some what do you call, some picture with some frame, so just we are cutting the just faces, just face. But inside this data set, I think it will be correct. We need to do it, but instead of you, if you're using some extra data set, so you need to do some this one. Okay, so if you also use xyz in the faces also, but you can do this one. Okay, and we are making our image into a grayscale format. You can see here gray equal to cbt.cb color in a grayscale format. So after Converting this image in a grayscale format, we are going to cut down image into 32 by 32. Okay, you can see here we initialize our image size to the 32. So that's mean put here 32 comma 32 what called image size comma image size. That's mean these image being converted into 32 by 32. Okay, you can see here in this dataset folder there is some picture with some extra widget. You can see here some picture is a small. Yep, you can see here some small or some big or some wide, some height is some mismatch. Okay, so we are going to make this all picture into 30 by 2, 30 by 2. Okay, 32, 32, and it will easily detect. It will either detect the model and extract the feature from this picture and detect if the person is male or female. And now we are going to append all the data in our data list and also the target list. So if we got some exception here, or you can forget to import the some library or some code, so it will definitely give you error. So that's why you have to put here exception code. Okay, now we need to convert our image into normalization format. So you can see here we are going to import numpy as an, and we are also going to import warnings cause Tensorflow will give me some warning here. Okay, but still it will give me a warning. But if I run this, you can see here it will don't give me error. Okay, so data equal to np.array data by 25500. Why we have to put here this line np, I mean this line? Why we have to put here np.array data 255? Because we are going to divide this all the picture or all the pixel of this image into 255. That's mean this picture is actually converted into in the range of 0 and 1. Okay, so 0 and 1, so it will detect it. Okay, so first actually our model is trying to load our picture in a numpy array. Okay, so that's we have to put here this line. Okay, and we are going to reshape our picture in this format data and data dot shape 0 image size and the image size is the 1. That's been 4. Okay, then we have to put here the array in also in the target, and we are going to use the keras.utils. We are going to import the np.utils and make these np.utils in a categorical format, or you can say one hot encoding. So new target equal to np.utils dot to categorical and the target. Okay, and we are going to save this one in this folder. Okay, training data target. So if I go here and see inside this training folder, what is this training folder? Yep, so let's delete it and data.mpy and also target.mpy. Okay, so if I run this shell, and you can see here it will generate two files, but actually it will take some time to generate this. You can see here static marks here. Okay, it will actually it will loading this. Okay, and sometimes it will give me error. Why? Data is not different. Okay, we have to run this code, but still it will take some more amount of time. Okay, cause data set or female. Okay, yeah, we need to run this shell again, and actually it's taking more amount of time cause there are more than so more images. Okay, so if I go here and in the data set, you can see here and go to the properties, you can see here more than 1000 or maybe, yep, you can see here 1173 files. So it will actually convert this image into grayscale format and resize it, so it definitely will take some time. Okay, so you can see a static mark. So after it will loading, so it will generate two files. Okay, and we are going to save it into this one, and also we need to load this one. So np.load. So after loading this, we need to make our model. Okay, so I think it will take some time. Okay, no problem, we are going to discuss this one. So after it will generate this file, we are going to load this one. So we are going to import numpy as np and load this one. Okay, so now it's time to create our model. You can see here from keras.model we are going to import the sequential, because we are going to create a sequential model, and we're going to import keras.layer and dance layer activation function and the flatten layer and the dropout. flatten is fully connected. Yep. And from Keras layer, we are going to import the convo 2D for our convolution layer and max pooling layer and the model checkpoint. So actually, we are using the model checkpoint to check some different types of model. It will generate so different types of model. You can choose anything, okay, anyone. Just run it, and I will see you. It will see you. Okay. So we are actually define the filter 64 and the kernel of the filter 1, filter 2, and the pool size 22, and the number of node we are going to put here 64. Okay. And now we need to create our model. So model equal to, we are initialize our model as a sequential model, and add this model dot add convert 2D 32 and size of kernel 1. Size of kernel 1 is 3,3, and input shape we are going to put here. This input shape is data of shape, because we are going to put here the shape of the data. That's mean you can see here data. So this is our the shape, and target is for target. So it is our shape or the image shape, because we are going to convert our data into a numpy. So this one, and we are going to use activation function, the rel activation function. Okay. And we are also put here a hidden layer. So you can see 32 size of filter 1 activation rel, and we add a polling layer here, poll size equal to size of poll 32, and we also add activation or convert to D. Convert to D 64, and size of filter 2 is also with 33. Activation function is relu, and same method 64, and the size of filter 2 3,3, and the activation function is the relu. And we also initialize our max pooling layer here, pool size equal size of pool. So our size of pool is 2,2, and we put here dropout. So already get it will generate some overfitting error, so that's why we put here a dropout layer. So dropout is 0.5, and we need to convert our image into model into a flattened layer or a fully connected layer. That means some linear format. So you can see here model.add and the flatten, so it will convert this image into a linear format. And after make this a linear format, we are going to put here the dance layer of the 64 node, number of node. We initialize this as a variable in 64. I think it will definitely take time. Okay, it will actually loading. Okay, so now, so you can see here after we also put here the dropout at 0.5, and the dance layer you have to put here number of classes. So what is the actual number of classes? So number of classes inside this folder, you can see here we have the 2 classes. So first one is a male, and another one is the woman. So that's when you have the 2 classes. So you have to put here 2, and the activation is a softmax. So actually softmax is help us to do some binary classification. So what is it? 2. So you have to put here softmax, or another activation function is softmax, and what is called, I forget, softmax, and another one is maybe, I don't know, I know, but actually in this time I'm not remember it. Softmax and what's that, sigmoid. Yep, sigmoid. So another one is the sigmoid function, so you can also use this one. And we are compiling our model, so you can see a model.compile, and loss equal to categorical entropy. And optimizer, we are going to use Adam. So there are various types of optimizer, so like gradient descent, AtomX, and also on. So it will actually loading. Why? Okay. And we are going to use the matrix as the accuracy matrix, and we need to split our data into train, test, split data. So we are going to import from sklearn. From sklearn under model selection, we are going to import train, test, and split, and we are going to split our data into a train data and the testing data. So train data and test data, comma, train target and the test target. Cause we have a dependent and the independent feature. So our independent feature, you can see here data, and our this one target. I don't know why it takes some time, cause the picture is small. Okay, 1000. Okay, no problem, it will take some time. Okay, and we are initialize our checkpoint here. So checkpoint equal to model checkpoint, and we are going to save it one in a some format one. So you can see here, and we are going to use monitor as a val loss or validation loss, and bubbles we have put here 0 as it is the default, and save best only equal to true, and the mode equal to auto. So it is auto mode, it will automatically save our model in our training folder. And for history, you're going to put here model.feed. So inside this feed, you have to put here the training data and the training target. And the epoch, we are chose here 20. So you can choose, it actually depend on you. And callback, we are using checkpoint. And the validation speed, we're going to put here 0.2. Okay. So this data is validated into 0.2. That's mean 20%. Yep, it's right now, it will actually run. So yep, I think it will save our model. So check it inside this training folder. Okay, open. Yep, data.npy and the target.npy. So now it's time to load our model here. So shift enter. So take some time to load it. Okay, yep, it will load it right now. So now we need to split our data. So shift enter. So you can see here from sklearn model section, you're going to import the train test script. So it takes some time because we have a so more amount of data. So I think this file is more than 6 MB, 6.5 MB, and target is not because we have just two classes. That's why you can see here 13 KB. So definitely take some time. Okay, now it will okay. So now we need to check the checkpoint with history. Okay, so it will take some time. You can see here 588 sample validate on the 148. So it will take some time. You can see here eta equal to, this means seconds, and the loss equal 0.70, and the accuracy is right now 0.4745, and validation accuracy is 0.5473. It will take some time. Okay, so after training this, it will generate some folder here. Inside this one, you can see here it will actually generate this one. So 0.7, it's, I think it will, before it will generate some another one. Okay, don't worry. So you can see our validation accuracy increases just so in this case I'm going to just interrupt this one, our kernel, because it takes some time. Okay, so you need to do as it is in your way. So I already train it. You can see here it will generate this type of folder, and some definitely will give me error because I interrupt it here. Okay, so when it will load, you can see here these types of folder. So you need to choose something. You can choose 0.4 or 0.7. So you need to choose inside this model, you need to choose someone. Okay, so which one give you the correct best output? So in my case I chose 0.007, model 007. So let's minimize it. You can see here I chose the 0. Model 007 model. So you need to run this. Okay, definitely it will give me error because I stop this. You can see our validation accuracy right now 0.6419. Okay, or I can run this, no problem. Okay, so so you can see here we need to load our model, training model equal to 0.7, or let's run this and check all the steps by. Okay, so after it will loading this, okay, it will give you some model file. I'll trying to show it. It's better to show it. Okay, or other I can pause this video. After it will take some time to load this. So now you can see here our accuracy is 0.9150. That's mean 91%. Okay, and our loss is 0.1813, and validation accuracy is 0.848243. Okay, so now we need to load our model here. So from Keras.model, we are going to import our model. So you can see here after training this, you can see a so more amount of file here. Okay, so more amount of file. So you can choose as it is, or you can choose like say 0. Model 016. Just you need to change this one 016 here, 16 this one, and or in my case I'm going to choose 007, or you can choose 16. So it will definitely give you the correct output. So now, So from Keras.model, or you're going to import the load model, and you're also going to import CV2 because we are dealing with real time, and NumPy as NP, and we need to detect our faces. So after detecting our face, we are creating a dictionary here. So label dictionary equal to 0 equal to male and 1 for female, and you put here some color directory or color format. So this is the red and this one is the gray. Okay, so now, so you're creating a loop. So while true, we are going to read our frame. So red and comma image equal to red cap dot read, and we are converting our image into grayscale format. Okay, because in our pre-processing step, we are going to we are convert our image into grayscale format, and we also resize it. Okay, so now in this real time, we are going to also do this step by the way. Okay, so you can see here, after detecting it, we are iterating all the value from the faces. So after detecting this, we are going to cut this one in the y scale, y plus height, and y x plus width, and y plus height. Okay, and you can see here a resize equal to cb2 resize equal to face emg and 32 by 32. So it is our image size. Okay, and we also make this image in the normalized format. So that's why we have to put here divided by 255.0, and we are going to reshape our image into this format 132 32 comma 1, because we are resizing our image into this format. So you can check here data comma data the shape image size in the one. So now we need to convert our image this format. Then we need to predict our result here. So model equal to predict dot reshape, and we are going to use argmax. So actually it will help us to uh, give me the correct output. So if that's mean if our value is 0.97 or let's say 0.20, so it will give me the, let's say, 0 or 1. So we are going to use the argmax function to give it. So inside this result function, we are going to put into our label, and we will create a rectangle over our faces. So after creating our rectangle, we are also create a rectangle of our label. So it is our predicted label, and we put here the put text of this one inside this label folder. So you can see label dict equal to label. So label dict our actually this one. So it's our label dict. You can see here for 0 it will be male, and for 1 it will be female. Okay, so now we are going to run this cb.imshow, show it, and what case one. So if anyone press ESC, or you can say Q, so it will work. But in my case, just I'm doing some extra work, so ESC, so it will work. Okay, so shift enter, shift enter, shift enter, shift enter. So it will load right now. Take some time to load this because our model is right now prepared for new model. So that's why it will take some time. Okay, yeah, you can see here it will detect my face as a male person. So we put here some picture of the female of the with marks also. It will detect the face as a female. Yeah, you can see here. Okay, another picture. So this one female. Okay, so this is the video. So hopefully you will enjoy this video, and make sure to subscribe my channel, and don't forget to hit the bell icon for never missing an update.